While I'm doing this presentation, I had a happenstance. I did what you're about to see demonstrated, I had to do for myself, for my own computer, a couple of weeks ago. And it involved all of the stuff that we've been talking about on these Sundays with the Windows thing. Go to settings, use this button, use that, change this, change that. And also I'm forever getting asked by people on here and by people in the real world about speeding up their computer. And this is a quite interesting way of doing that. A GPU is called a graphical processor unit, and it's a bolt-on to a graphics card. It's like a single chip that's got a couple of thousand little tiny picks on board. Little tiny, like the 12F675 or the 509, the little tiny, only a couple of words of memory, only some very, very basic processing power. But the point is that they're all in parallel. And so if you're going to do something a million times, if you do it with 1,000 processors at a time, it takes a lot less time than if you do it with one processor a million times, even if that processor's much quicker. They're used for graphics intensive applications, graphics design. The gaming community use them a lot. They want big, powerful graphics. I think I've got an example. Have I got an example? Show them your example, Charles. There we go. Oh, move the good-looking fella with the haircut out the road. There we go. That there is a woman that never existed, and a horse that never existed, on a planet that never existed, with trees that never existed, under a moon that never existed. The whole thing's a mathematical model. But in order to make that drawing was what's called ray traced. That means that the computer started, and for every one of those pixels, and it's 1,000 pixels by 600 across, so what's that, 600,000 pixels? So just 2/3 of a million times, the computer worked out that ray of light, where does it come from? If we look close to the bottom there, there's a pixel in the water that reaches your eye and it comes from the water. Now, to get to the water, it has to either have bounced off the horse or bounced off the sky. So I've got to trace back where that went to. And if it bounces off something else, every time it changes direction, the amount of light gets changed by the luminosity or the reflectivity of the surface, the amount of light that's incident. There's a whole load of calculations that's to be done for every one of those rays, and there's 600,000 of them. So for that reason, doing graphics like that takes a lot of processing power. And if you've got a GPU, then it will do that because it's maybe got 1,000 or 10,000 processors that can do that stuff in parallel. It's also recently become very trendy to do Bitcoin mining and machine learning and artificial intelligence. Machine learning involves a great big matrix of data and going through it and looking, you've heard of the term big data, basically looking at lots and lots of data for patterns and for correlations and all that sort of stuff. If you've bought a top-end graphics card, if you've spent money on a graphics card, then it's probably got a GPU on board. If you've got a decent laptop, it's probably got a GPU on board. Or you can buy a standalone unit. The graphics processing unit, the GPU, doesn't have to be on a graphics card. You can actually buy a GPU. It's just a socket that plugs into your motherboard, and it works independently of the graphics card. It's for doing calculations. It's not for displaying graphics. It just happens to be that it's used a lot for graphical processing. You may already have one. Now, where's my wee button to push here? I have to move him again. This is where it goes back to what we've already done on these Sunday sessions. Device Manager will show you under display adapters if you have something like an NVIDIA or a Radeon or an ATI card. And if you look at the Task Manager under Performance, it will tell you if you have a GPU, and there'll be GPU performance graphs there. And if you don't have a GPU in the task manager, or you don't have a GPU supported graphics card in the device manager, you don't have. However, this happens quite a bit. This is my laptop that I'm currently using. And it's got two display adapters. An Intel high definition graphics 4600 and an NVIDIA Quadro. This is a Dell laptop. And when I go to the task manager, there's two GPUs in there, GPU 0 and GPU 1. Now, GPU 0 is the Intel, and it's doing the work. If you look there, you can see there's a little bit of processing going through, a little bit of graph there, and it's on GPU 0. GPU 1, the Quadro, the NVIDIA, doesn't have any work going through it, which is a pity, because the NVIDIA Quadro is about 150 times more powerful than the Intel graphics card, which is where this conversation is coming from. If you've got a GPU, it makes things go quicker. If you're using graphics, it makes them smoother and it's quicker. And did I mention that it makes things go faster? Disadvantages: it takes extra power to run a GPU. It's a great big silicon chip that takes a lot of power. I mentioned the Bitcoin mining on the way through. Years and years ago, it was very trendy to mine Bitcoins. And as a result, GPUs, you couldn't get one for love nor money because all these people were buying them and putting them in rigs to mine Bitcoins because they thought that's how they were going to make money. It turns out now that the power to mine Bitcoins, there's more power used mining Bitcoins than is used in Argentina, and just the amount of raw electricity that's being used. And so people are drifting away from that. And as a result, you can now buy GPUs again the past couple of months. The only thing is you can't get them delivered, but that's a whole other story. You have to have a GPU. You might not have one, in which case this whole discussion's moot. Not every application, if you've got a word processor or JAL, then a GPU is not going to make any difference to that. Your Arduino, forget it. No GPU Arduino doesn't help, not for this. JMRI, no, not for you either. Not every app will benefit from it. And those that do, you might have to either get a special version of it, or you might have to get a special driver, or you may have to do some work. But mostly you don't. I'll explain that in a minute. Now, when I was talking about my laptop a minute ago, I said that very often you put a GPU in a machine and the machine's got an Intel chipset because the vast majority of processors are Intel processors. And the vast majority of chipsets on motherboards are Intel chipsets. And if your motherboard has got an Intel chipset and an Intel display driver on it, it will use the display driver that is on the motherboard. And so it'll ignore the fast, expensive GPU that you just plugged in, or that Dell plugged in for you, unless you tell it that I actually want to use the faster processing power here. And so I've got a wee example that I've been working over for the last couple of weeks, and hopefully I can show you. This is a radio knob for a software-defined radio, an SDR radio, like ham radio for people that can use computers. And it's 3D printed, as you can see, and it's got the knurling round about it. There it's there. I have to hold it up against my jersey. There it's there. It's a beautiful thing. And the knurling round about the edge of it is the same knurling that we did for, you remember the little finger drivers that we did a number of years ago for getting into sneaky points. If you can't get in with a screwdriver, you would use this little white knurled thing that you can plug in a 6mm screwdriver bit and you can get into places with. And the knurling is great, but if you look at it objectively, that knurling is lots and lots and lots of little pyramids. And as the project gets bigger, the knurling stays the same size. So it's not a case of if you make the knurling, if you make the diameter of the thing twice as big, that you get the same number of pyramids, but they're all bigger, you get more pyramids. And more pyramids means more faces, more corners, more edges, more work for the computer program that's demonstrating it. So the bigger the drawing gets, the physically larger diameter the model is, the more GPU or the more processing has to be done to render that image. And I was making this thing for, as I say, an SDR that I'm currently working on for somebody. And I found that as that get bigger and bigger and bigger, that my OpenSCAD was getting slower and slower and slower, to the stage where I couldn't. If you've used OpenSCAD, you have a model and you can flip it up and turn around about and look through. You couldn't do that anymore because it was becoming so slow. So back to doing what we're doing on a Sunday. I go to Systems, and we'll follow the little yellow ellipse here. Control or Windows and I, the Windows key plus I brings up Settings. In Settings, I go to System. In System, I go to Display, and from Display to Graphics Settings. In Graphics Settings, I can choose a classic app or a Windows app. Now, a classic app is a program, what we would call a program. Any program that you've ever installed in your computers, what Windows are now calling a classic app. The non-classic apps are those blocky things that Windows 10 has got in the start menu, you know, the settings and the new version of the calculator and all the things that you download from the Windows store. Whereas anything that we're using, it's a normal program, is what's called a classic app. So I chose classic app and I pressed browse. And then I went through my machine till I found the executable for OpenSCAD. And having found it, I pressed add to add it to the list. And so now I've got graphics settings that I can alter for OpenSCAD. I go to the options button there, and I can choose either the power saving GPU or the high performance GPU. System default is always the power saving GPU. But if I actually want some power out of this, I need to go to the high performance GPU. So that's what I did. I clicked onto the high performance GPU and I pressed save. And once I've done it with OpenSCAD, I just kept going. And KiCad and Eagle are two printed circuit board designers that I use. Inkscape's a drawing program. FreeCAD and FlatCam are things that I'm not telling the hurdy-gurdy club about because they'll just want them and I'll just have to support them. Digilant Waveforms is on the PC, oscilloscopes and logic analyzers and electronics type stuff. And Blender is a 3D modeling program, like see that thing with a woman and the horse earlier on, that was done in Blender or Povri or some of these things. So anything that's appropriate, I add it, I browse, I bring it in here, I then go to its settings and tell it, oh, by the way, you run on the GPU. And here we go, back to my little knurled knob. Without the GPU, there's two renders in OpenSCAD. There's the quick render and the complete render. Without the GPU, it went from 30 seconds for 50 millimeters and from 2 minutes down to 4 seconds. And the complete render took from 6 minutes down to 5 seconds and from 10 minutes down to 8 seconds. So it's made a hell of a difference to the usability of the program. Right now, it might not be that anything you're using needs a GPU, and it might be you don't have a GPU, but it might be that this is something that might be useful and might save you some grief and might save you having to throw out a PC that you think is getting slow. And it's not really getting slow, just the software is getting more complex. That's it. Any questions?